Well, hello guys. Time to work on the test review over area and surface area. The first two are ones we did together in class. I'm going to go ahead and redo them now in case you were absent. Both of these are hard challenge questions and they both show up again. So I'll go a little bit faster next time, but we'll talk about them right now. Number one says the surface area of a cylinder is 42 pi. The height of the cylinder is 4. What is the radius of the cylinder? So we know that the surface area of a cylinder is 2 pi RH plus 2 pi R squared. You got to know your formulas. We talked about those quite a bit. Plug in the parts that we know. We know the surface area, so that's 42 pi. We know the height, so 2 pi times R times 4. The height's 4. And we're looking for the radius. This is a challenge question because you have to factor to solve. First thing I'm going to do is I notice every single term can be divided by 2 pi. So 42 pi divided by 2 pi, the pi's cancel out. That leaves me with 21. Here the 2 pi's cancel out, leaving me with 4r. And here the 2 pi's cancel out, leaving me with just r squared. So I canceled out all of those pi's. All the 2 pi's, really. We reduced by 2 pi. And now we're left with an Algebra 1 factoring equation. So first I'm going to put it in standard order. Standard order would be r squared plus 4r. And then I'm going to subtract the 21 over so I can cancel it out. So it's going to be minus 21. And that's going to equal 0. And now we get to factor. We've done this throughout the year. What factors of 21 subtract to equal 4? That's going to be 7 and 3. How do you get positive 4 out of 7 and 3? You're going to add 7 and subtract 3. So the radius could be negative 7 or positive 3, but you can't have a negative radius, so this one turns out to be 3. You're going to have a question very much like that on your test. Next question is quite a bit of work. This is a level 5 version of the question we did on Monday. This is straight off SATs. You should be able to do this in about 5 minutes or so on an SAT, just so you know. Maybe a little bit more, maybe a little bit less, but in that zone. Not an easy question in the sense that it's a lot of work. What makes it a level 5 is there's no graph. And making a makeshift graph is not a good solution because unless it's absolutely perfect, it's not going to be very helpful. So what you have to do is rely on your algebra skills. So it says find the area bounded by the region created by these lines. We need to know where they intersect, but we don't have a graph. So what we're going to have to do is a system of equations. We're going to take the first two equations. What we're essentially doing is we're taking this part of the equation and plugging it in for y. Or your Algebra 1 teachers might have said something like set them equal to each other. So it's y equals something, y equals something. We're going to take those somethings, in this case negative 1/3 x plus 4 and negative x plus 12, and we're going to set them equal to each other. And we're going to solve. Now if I'm doing this, the first thing I do is get rid of the fraction. So if I multiply everything by 3, I would now have negative x plus 12 equals negative 3x plus 36. You have to multiply everything by 3. And actually, after you guys practice these a little bit, the most common error I see is right here, is getting your x's on the same side. People mess it up all the time. If I have negative x and negative 3x, I'm going to move the 3x over, add the 3x, and I get 2x. Subtract the 12 over, and I get 24. So x equals 12. That's where they intersect. But I need to know the y-intercept, or sorry, the y-coordinate. I can plug x into either one to get the y value. And if you have enough time, plug it into both because it should be the same answer for both. If I plug in 12 here, I would get negative 1 plus 4, which is 3. If I plug in 12 here, wait, is it 12? Oh. Nope. See, that's why we check our work, because it's not 3. If I plug in 12 here, 12 divided by 3 is 4. This is negative 4 plus 4, which is 0. And this is negative 12 plus 12, which is 0. So the coordinate is 0. When I plug in 12, my y coordinate is 0, so that is the coordinate 12, 0. But you got to stay strong. That is just the first equation. We have two more. We need to do the first one with the last one now. So we need to know where they intersect. Negative 1/3 x plus 4 equals x this time. Multiply everything by 3. Get your x's on the same side. That's where people mess up. I'm adding x over there. Be real careful. So the x coordinate is 3. Plug it in. You can do either one. This one's really easy. If x is 3, then y is 3. So x and y have the same number. That's the coordinate 3, 3. So those intersect at 3, 3. And then the last combo would be the second one and the third one. And that would be negative x plus 12 equals x. So 2x equals 12, x equals 6. And again, if x is 6, y is 6. So that would be the coordinate 6, 6. That's phase 1. Phase 2 is to make a makeshift graph. Oh man, I don't know why my pencil is doing that lately. So do a makeshift graph. It doesn't have to be perfect, but we need a rough estimation of where these points would go. So 12, 0 would be like way down here at 12, 0. 3, 3, like right 3, up 3, maybe something like that. And then right 6, up 6, something like that. So we have 3, 3, 6, 6, and 12, 0. And that is our triangle that we're going to find the area of. We can't do the strategy from last time because we don't have an actual graph provided. If we did, we could maybe do something like this and then do the two smaller triangles, and that'd be a lot less work. But because we don't have that option, the next best thing to do is to draw a rectangle that is too much space. So a rectangle that goes through these vertices, oh man. So a rectangle that goes through these vertices. I'm not good at this, clearly. All right, that's as good as I can do. And what that does is it gets too much area. But we can get the area of the rectangle and subtract the 3 right triangles. You notice that extra space is right triangles. So we want this area. We want the blue space. So let's start with the big rectangle. What are those dimensions? From 3 to 12, the length is 9. From 0 to 6, the height is 6. So the rectangle is 9 times 6, which is 54. So the area of the entire space is 54. Then let's do this green space. The green space would go from 3 to 12, which would be 9. Over here, we're going from 0 to 3, that would be 3. So the green triangle would be 9 times 3 divided by 2, which is 27 divided by 2. Then we have this brown triangle. The brown triangle would go from 0 to 6, that would be a height of 6. And then from 6 to 12 would be a base of 6. So the brown triangle would be 6 times 6 divided by 2, which is 18. And then finally, this last triangle over here, we'll do orange. This triangle would be a height of 3, right? From 3 to 6 is 3, and then this is also 3 to 6, right? If you start at 3, 3 and go to 6, 6, you're going up 3 over 3. So the orange triangle would be 3 times 3 divided by 2, which is 9 halves. Combine all those, you would get 18, and then 27 over 2 plus 9 over 2 would also be 18, so this adds up to 36. So 54 minus the 36, and the final answer would be 18. Woo! That's a level 5 question. The question on the test is not a level 5. You will have to do this, but you will have a graph provided, which eliminates, you don't have to do all this work. You can graph it to find those intersections. And that reduces how difficult the question is for sure. All right, here we have the lateral surface of a square pyramid. It has a height of 24, and the base edges are 16. Those are labeled for us. So one of the things I want to just show you again real quick are some of the situations you have to be aware of. First off, squares are pretty unique. On a square, the apothem, right? So we have the apothem here, is half the side length. So for this problem, if the side is 16, then the apothem is going to be 8. And that's important because we're going to have to use the apothem and the height. Remember, they gave us the height. So there's another right triangle here where the height and the apothem connect to get you your slant height. So we're going to have to make sure that we're using the correct numbers in the correct places. There was a picture provided here, so it's a little bit easier to see, but this would be 8. Here's the height, the apothem, and the slant height. So and we just want lateral area. So lateral area is 1/2 PL. Well, if this is 16, then P will be 16 times 4, which is 64. The slant height we got to get. We got to do this right triangle that has 8 and 24. So what I would do is reduce those numbers, divide by 8, that would be 1 and 3. So that would be 9 plus 1. This would be the square root of 10. Multiply the 8 back in, and that's 8 root 10. So the actual final answer is going to be 1/2 times 64 times 8 root 10. If you had to leave it exact, that would be 32 times 8, which would be 256 root 10. But they asked us to round to the nearest whole number, but practice leaving it exact. So 256 times the square root of 10 rounds to 810. Whoop. So the answer is 810. Next question, it didn't come out like I thought it did. Whatever device I was using, this looked gold, and it's clearly not in this picture. That's my bad. But if you notice, I said the entire wedge is gold. I know the colors look off. The whole thing's gold. So I apologize. It didn't turn out the way I wanted it to. It says we are cutting a 65-degree wedge out of the cylinder. That means that this piece that's gone is our 65 degrees. The piece that remains, the rest of it, would be 295. It's a full circle, so that would be 295. That's really important. They tell us that the radius is 5 and the height is 9. So the radius would be this line here. That's going to be 5. And then the height, the height would be like here, and that's going to be 9. So we have a radius and a height. There's a lot of ways to do this, but I think it's easiest to do it all at once as one big shape. So how would I get an entire cylinder? The surface area of an entire cylinder is 2 pi RH plus 2 pi r squared. But we don't have an entire cylinder. That's if we have all 360 degrees. But we have 295 out of 360. And then because when we cut the wedge out, there's 2 new surfaces. So I need to be very clear. When you do this, you're getting what's left over of the original cylinder. The original cylinder would have been the top, the bottom, and the lateral sides of the cylinder from the original. These 2 rectangles are new. You couldn't see these rectangles until it was cut, but we want the whole thing to be gold, so we got to paint that gold as well. So we need to add the two rectangles into the mix. So now we just need to plug these numbers in. That's going to be 295 over 360 times 2 pi times 5 times 9 plus 2 pi times 5 squared. A lot of people are forgetting these outer parentheses. Just so you can see it, if I left those off, the only thing that the 295 over 360 hits is the first term. We want it to hit both terms, but if you type it in like this, it won't do that. You need to have those parentheses on there. Plus the two rectangles. Well, the rectangles would be just the radius and the height. Those would be 5 and 9. So that'd be 2 times 9 times 5. So this would be 90 pi plus 50 pi, which would be 140 pi times 295 over 360. So I'm going to type that in my calculator. And that would be, so this part would be 2065 over 18 pi. And then over here, this would be plus 90. So that's the exact answer. But they also are telling us that it cost 7 cents to paint it per square inch. So it's going to be that answer times 7 cents. Again, I'm going to put parentheses around it, and I'm going to type that in. So that would be 2,065 over 18 pi plus 90. Make sure there's parentheses around that, times 7 cents. And that would be $31.53. Remember, money is going to be rounded to the nearest hundredth. So if you're working with money, it's always going to be the nearest hundredth. I have never seen it not that way. But it does tell you in the question, round to the nearest hundredth. It's dollars and cents. So we took the surface area times how much it cost. That's what we did. Find the surface area of this figure. Okay, we've done this problem in class before with different numbers. I know it's hard to understand these situations. You're just going to have to keep trying your best. But looking at this, what if I got the total of the box? Right, we have this box. That would be the front, back, left, right, and top. Well, on the top, we have a circle missing. So if I do the total of the box, I need to make sure I do minus one circle, because that circle is not a surface. Remember, we're talking about surfaces. If you were painting this shape, could you paint that circle? No, it's not a surface. Then let's focus on the cylinder. And also, people get confused when I talk about this, but you've got to understand, lateral means everything but the bases. So on this cylinder, this circle is one of the bases. The other base is covered up. But I need to add that circle, because we can see that circle. But then we can also see the lateral, which is everything but the bases. So I'm going to I'm going to add the lateral of the cylinder. So this is my plan. The total of the box minus the circle that's covered up, plus the circle on the top, plus the lateral would get me everything I need. Now you might be noticing right here, those cancel out. So really all we're doing is the total of the box plus the lateral of the cylinder. That's PH plus 2B for the box plus 2 pi RH for the cylinder. And that's going to be our surface area. So I'm going to go and work on the box. The box has a base of 14 by 8. And if you're not told which one to be the base, I highly recommend you make the bottom the base. Not only does it just makes it easier to think about for most people, but every textbook and online resource I've looked at, even if they don't tell you, they make the bottom the base. So it's just kind of assumed, make the bottom the base if you have a choice. And this one we have a choice, so we do that. I need the perimeter and the area of that base. Well, the perimeter would be add up all the sides. 14 plus 8 is 22. Times 2 is 44. So the perimeter of the bottom is 44. We add up all the sides. The area of the bottom would be 8 times 14 would be 112. 80 plus 32. And then the height of the box would be 12. So the total of the box, we'll start with that, is PH plus 2B. And so that's going to be 44 times 12 plus 2 times 112. I'm just going to type that in. 44 times 12 plus 2 times 112, and I get 752. That's the total of the box. Then we're going to add the lateral of the cylinder, and that is 2 pi RH. So we need those numbers. R is 4, and H of the cylinder is 8. So that's plus 2 pi That's 2 pi times R times, I forgot, 8. So that would be plus, that would be 32 pi. So that's the exact answer, but they want us to round to the nearest thousandths, but practice leaving it exact. So that's the exact answer, but I need to type that in. 752. Wait, I messed up, sorry. 8 times 4 is 32 times 2. I forgot to do times 2. Sorry, guys. 30, so it'll be 64 pi. My bad. So 752 plus 64 pi would be the situation. And that is 953.062. So it's 953.062. Bada bing, bada boom. Next question, we have find the area of the region bounded by the graph. So we did this week. That'd be 2/3 x plus 2. So we got 2. We're going to go up 2 over 3. Up 2 over 3. So here's the first line. Then we have y equals 0. Y, that's hoi, hoivux, y, horizontal. X equals 3, vux, vertical. And x equals 9, vux, vertical, once again. So the bounded region would be this section in blue, which is just a trapezoid. And we need to find the bases and the height. The bases would be the parallel sides. So the bases would have, let me erase this extra red. The bases would have a height of 4 and a height of 8. Or, sorry, length 4 and length 8. The height would be from 3 to 9 would be 6. So it's the average of the bases times the height. That would be 6 times 6. That would be 36. All right, next one. So this is a lot like number 1. It's the, I'm going to go a lot faster to this one. The surface area is 2 pi RH plus 2 pi R squared. So 90 pi would equal 2 pi times R times 12 plus 2 pi times R squared. Divide everything by 2 pi because they all are divisible by 2 pi. And we get 45 equals 12R plus R squared. Put it in standard form. You would have R squared plus 12R minus 45 equals 0. What factors of 45 subtract to equal 12? That would be 15 and 3. And because it's plus 12, it would have to be plus 15 and minus 3. So R equals negative 15 or positive 3, but a radius can't be negative, so it would have to be 3. Find the surface area of the solid created by rotating the bounded region of the graphs. So x equals 5 and x equals 10. Vux, vertical, x equals 5, x equals 10. And then y, horizontal, y equals 2. Horizontal, hoi, horizontal, and y equals 8. The bounded region is that rectangle there. So I'm going to draw my rectangle. and delete the excess. And it's reflected across, or it's rotated about the y-axis. So I'm going to paste the reflection on the other side of the y-axis. Maybe. There we go. And it's going to go, where was it? X equals 5, so it's going to go to negative 5. All right. And then we connect opposite vertices with a circular motion. This is a wide circle, but it would create basically like a tube, or you could think of it as a donut, but it would be a cylinder-shaped donut, or a roll of toilet paper. And I'm going to delete these solid lines that we don't really need to see the picture anymore, but we need like maybe these dotted ones here. So it's a cylinder with a cylinder cut out. We've done this exact problem before. We need 3 numbers. We need to know big R. So big R is from the center to the outer edge, which would be 10. We need to know little r from the center to the inner edge, which on this one would be 5. And then we need to know h. H is the distance from 2 up to 8, which would be 6. So 10, 5, and 6. And then we need to have a good plan. That's a little r. I don't know what's going on. Oh, that's an h. Sorry. What would be the plan here? Well, pretend there's no hole. You would do the entire cylinder. So let's say you painted the entire cylinder. And then you drill this hole through it, right? You drill this hole out. What did you paint that is now gone? Well, the thing you painted that is now gone are the 2 small circles, or the 2 inside circles. But now you have this new surface, this inside surface. If you're holding a roll of toilet paper, it's like the cardboard part. You can touch that. You can paint that. That is the lateral of the inside cylinder. The lateral of the small cylinder. So the total of the big cylinder would be 2 pi big RH plus 2 pi big R squared. Minus the 2 small circles would be 2 pi little r squared. Add on the lateral of the inside would be 2 pi little r h. And now we just plug in. So when we plug those in, we would have 2 pi big R times h plus 2 pi times big R squared. Minus 2 pi times little r squared, that's minus the 2 small circles, plus 2 pi times little r times h. This would be 120 pi plus 200 pi minus 50 pi plus 60 pi. So those together is plus 10 pi. Put those together, that's 320 pi. Plus 10 pi is 330 pi. There we go. All right, we haven't done this in a little bit. We got a dodecagon. Please read carefully. And we know that the area of the circle is 100 pi. So the area of a circle is pi r squared. We know that 100 pi equals pi r squared. The pi's cancel out, so r must be 10. R squared equals 100, so the radius of the circle is 10. The absolute key to this question is drawing the most useful radius. Oh, excuse me, you have a lot of choices. If we go to the center of the circle, we could draw a radius. Oh my pencil does that so much now. We could go to the edge of the circle, but that doesn't really help us if we draw it there. But what if we drew it to the edge of the circle here? That is a very useful radius. We know that's 10. But if we draw the apothem of the dodecagon, now we can use that 10 to work on the dodecagon. It's the radius of the circle, but it's also the radius of the dodecagon. So let's go over here and work on the dodecagon. There are 12 sides, so how many of these red triangles would fit? It'd be 24. So we have to do 360 divided by 24. That's going to be 15 degrees. And we need to know this side and the apothem. So we're going to have to get tricky with it. Dun, 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 dun. So we're going to do sine and cosine. Sine of 15 would equal opposite over adjacent. So that side would be 10 sine 15. And then let's do the A one. That would be the cosine of 15 equals adjacent over hypotenuse. So the apothem is, oops, that'd be 10. The apothem, oh my, what am I doing? Is 10 cosine 15. So the area of this triangle would be 1/2 times the base, which is 10 sine 15, times the height, 10 cosine 15, times 24 of them. I'm going to do that over here. So that would be 10 times 10 is 100. Half of 24 is 12. That would be 1200 sine 15 cosine 15. So that's the area of the dodecagon. But they want the percentage of the circle covered by the dodecagon. So if you remember, percentage equals part you care about divided by the whole times 100. So the percentage here is going to be the dodecagon divided by the circle times 100. Well, so that means it's going to be 1200 sine 15 cosine 15, the dodecagon, which is what we care about on this one, over the circle, which is 100 pi times 100. The 100s would cancel each other out, but I don't care too much about that. I'm going to type this in. 1200 sine 15 times the cosine of 15 divided by 100 pi times 100 is 95. What are we rounding to? Nearest thousands. 95.493. And that makes sense. It covers a lot of space there. I mean, there's not much not covered by the dodecagon. Describe the effect on the triangle if its base is doubled and its height is multiplied by 1/2. So it's a triangle. The area of a triangle is 1/2 base times height. So this would be 1/2. The new base would be twice as much. The new height would be 1/3 as much. When you're doing this, don't mess with the original numbers. Let's actually pull those out. If I pull out the 1/2 base times height, right? I pull out 1/2 times base times height. What am I left with? I'm left with 2 times 1/3. So it's the original triangle times 2/3. It's times 2 times 1/3 overall, times 2/3. The surface area of Mount Rushmore is that. A replica of the famous mountainside was made and placed as an advertisement. If the replica is 16, has a ratio of 16 to 5, what is the square acreage of the replica? Okay, so 1280, the original over the replica, which we're looking for, would equal what? Well, if the similarity ratio is 16 to 5, the area ratio will be 16 squared over 5 squared. That's going to be 256 over 25. So in order to work with area, you have to use an area ratio. This is in linear units. We need square units. In order to go from linear units to square units, you have to square the number. So that's why I squared the number. This is the ratio we're working with. So that would be 1280 times 25. So that's 32,000 equals 256x divided by 256. And the replica would be 125 acres squared. Got to make sure you square that similarity ratio. I'm not going to draw this. You can draw that. Find the lateral area of a triangular pyramid that has a height of 8. The base is an equilateral triangle with each side measuring 12 root 3. I think this is the hardest one on here to conceptualize. I'm going to try my best to get through it, but it's not easy. The first thing we need to understand is it's just lateral area. So the lateral area is 1/2 PL. So we need the perimeter and the slant height. So the perimeter we can get pretty quickly. Let's draw the base. The base is an equilateral triangle, and each side is 12 root 3. So the perimeter is going to be 36 root 3. Most people can get that pretty quickly. Oh, man. There we go. The slant height's a lot harder, guys. So listen, they told us that the pyramid has a height that's 8, not the triangle. The triangle height right here is not what they're saying is 8. I need you to try to see this, understand this. So remember on a square that the apothem was half the side length. But our base for this shape is not a square, it's a triangle. I don't have a triangle example to show you. But the apothem is not half the height. As a matter of fact, if you remember from first semester, the apothem of a triangle is 1/3 the height. So we're going to find the height and divide it by 3 to get the apothem. And then we're going to go into 3D, and that apothem, can you see the apothem back here? Is connected to the height, which they told us the height, and they make a right triangle with the slant height. That's a completely different triangle. So let's do that work. So first, let's get this height of this triangle. Well, this would be 6 root 3. This would be a 30, 60, 90. So this would be 18, right? Let's look at that triangle. If this is 6 root 3 and this is 30 degrees, you're going to do 6 root 3 times root 3, which is 6 times 3, which is 18. So that's 18, but I don't want that. I want this, the apothem, which if you remember from first semester is cut 1/3, 2/3. The apothem is going to be 6. Then I need a brand new triangle where the apothem is 6 and the height of the pyramid is 8. So once again, let's look at it one more time. This is really hard to conceptualize. We got the apothem. It was 1/3 the height of the triangle, not the height of the pyramid, the height of the triangle. I know this is a square, but you got to picture it being a triangle. Once we knew the apothem, what did we do? We turn the pyramid over and we go up from the apothem. That's the height of the pyramid. And that's a different triangle where the slant height's the hypotenuse, the apothem is the base, and the height of the pyramid is the height of the triangle. That's what I drew here, and that would make this the slant height, which would be 10. So the lateral surface area is 1/2 times 36 root 3 times 10. That's a very tough question. That's a lot of fun, though. Hopefully you enjoyed that. All right, let's look at the next one. The lateral area of a decagonal prism is this. So the lateral area equals pH, and they're giving us that answer. So 1276, the height is 6.38, would equal the perimeter times the height. So divide by 6.38. So that's 1276 divided by 6.38. The perimeter is 200. Okay. Find the surface area of the prism. So we want the entire prism. So if the bottom is a decagon, I'm not drawing a decagon, but we're going to have to do our right triangle work. If it's a decagon, there would be 20 of these. So 360 divided by 20, that would be 18. The perimeter, if I do 200 divided by 20, this would be 10. So one side is 20, but we don't have a whole side. Remember, this triangle is half of the side. So we need the apothem now. So this is the triangle we have to work on. So this would be the tangent of 18 equals 10 over the apothem. So the apothem is 10 divided by tan 18. So now we need to get the area of the base. So that would be 1/2 times 10 over tan 18. And there would be 20 of those on a decagon. All of that times 2, because it's a prism, there would be 2 bases. So times 2 for 2 bases, because it's pH plus 2 bases. Well, pH we know is 200. They told us that. All right, so we do this work. Well, these would cancel out. So that'd be 2 times 1/2 is just cancels out. So we have 10 times 10 is 100 times 20 would be 2,000 over tan 18. And then we got to add the 200 to that. So that's the total. They're telling us to round. So let me type that in. That would be 200 plus 2,000 over tan 18. And I got the wrong answer, so I did something wrong. Tan 18. Let me look, because I know what the answer is supposed to be, and that's not what I got. Half of 2 would be 1. 10 times 20. Is that 2,000? Yep, so 2,000 over tan 18 plus the 200 What did I mess up? Oh, this is not 200. The perimeter is 200. Sorry, the area is 1276. Sorry, that's 1276 plus that. Okay. I was getting a little worried. Let's go up here. Type in 1276. That's the correct answer. That would be 7431.367. And that would be our final answer. Oh, rounded to the nearest hundredth. So that would be 7431.37. 7431.37. There we go. So I was using the wrong number. I was using the perimeter, but it's the area. So it's the lateral area, pH, 1276 is what I needed. Okay, hopefully I didn't confuse you too much there. Next shape, what is the name of the indicated vertices? Well, if I'm looking at this, I'm going to have a hard time helping you with this, I'll be honest. But if you folded this up and over, this spot would be G, this would be A, this would be B, this would be C, this would be D, this would be E, and this would be F. And when you fold the whole thing together, like both of these lines would meet at A. They would all meet right here. So double question mark is A. Over here, both of these lines would be the letter D. So single question mark is D. Double question mark would be vertex A. All right. I think this is the last one. Find the area of the bounded region. This is just like number 2. This is a high-level question. We're going to do 3 systems. I'm going to go pretty fast through this because I've already kind of gone slow. But I'm going to make each equation, I'm going to set them equal to each other. Negative 1/2 x plus 10 equals 1/2 x plus 2. Get those on the same side. You could just multiply everything by 2, but because it's 1/2 plus 1/2, I know that's 1. Move the 2 over, so I know that x equals 8. Doesn't matter how you get there, but you need to know that x equals 8. Plug in 8 to either equation. Half of 8 is 4 plus 2 is 6. So y is 6. This is the coordinate 8, 6. The next one we're going to do is negative 1/2 x plus 10 equals 3/2 x plus 2. Add 1/2, that'd be 4 halves. That would make that 2x. Subtract 2, that'd be 8. X equals 4. If x is 4 divided by 2, -2, y would be 8. Make sure that's right on both accounts. 4 divided by 2, 2, 6, 8. Yep. So 4, 8 is my next intersection. And then my third situation would be 1/2 x plus 2 equals 3/2 x plus 2. Subtract 1/2, that would be 1x equals 0. So x equals 0, plug in 0, y equals 2. I get 0, 2. So those are my 3 coordinates. I'm going to draw my triangle. And I have 0, 2. I have 4, 8, right? 4 up 8. And then right 8 up 6. So just a rough estimation of where they go. We're going to draw this triangle. This is the triangle I need to find the area for. So what we did last time was we drew a rectangle that got too much. So the rectangle was too big. That's okay. We're going to find the length and width of the rectangle. Well, the length is from 0 to 8. The width is from 2 to 6. So the entire space is 8 times 4, 32. Let me double check that. Right 8. And then 2 to 6 would be up 4. Okay, so that's the entire space. Then we're going to have some smaller triangles. So this triangle would be 8. And from 2, wait. Messed up. Let's go back to brown. I did mess up. That's from 2 to 8. The entire thing would be 6, making it 48. I caught my mistake. Okay. Because the top is at 4, 8. So it's from 2 to 8. There we go. Okay. This one is from 2 to 6, which would go to 4. So the red triangle would be 8 times 4 divided by 2, which is 32 divided by 2, which is 16. All right, and then we'll do this orange triangle. This orange triangle, it starts at 6 and goes to 8, so that's up 2. And then it's going to go from 4 to 8, that's right 4. So that orange triangle is 4 times 2 divided by 2, which is 4. And then one more to go. Let's use this green color. And we're going to go up and over. That would be up. 2 to 8 would be up 6. 0 to 4 would be right 4. Green triangle is 6 times 4 divided by 2, which is 12. So we add all those together, and that is 32. So we subtract the 32, and I get 16. Let me check my answer. Looking good. Okay. That's a fun review. Hopefully that was helpful. I'll see you next time.